Hey, my name is Reuben Burch, and I'm the Jack Hatcher Chair and Associate Professor in Industrial and System Engineering. I'm also the Associate Director of Human Factors and Athlete Engineering over at CABS. Welcome to McCain, and let's go up to my office. Well, I got my first degree in computer engineering from Mississippi State, so I actually spent about 14 years in industry doing computer engineering work. Spent a lot of time working for NASA and the Navy and working in an IT department. And about 5 years before I came to Mississippi State, I was at FedEx Express, and so we did a lot of research with ruggedized handheld devices, autonomous vehicles, and that's ultimately what led me here. My last two degrees are in industrial engineering, and so that's why I'm in this department now. Because I really appreciated understanding how a person needs to use the technology more so than just how it's built. You know, here there's new energy all the time. In industry, it doesn't happen that way, so I really appreciated being able to come and work with students who were always excited to learn something new, which kept me excited. And so that's really one of the main reasons I left. But I came here in 2016 because I liked the idea of teaching. I like teaching new people. I like seeing people get excited when they learn something new. I also like to invent something, and I like to own or have control of the things I invent, and that's a thing you get to do when you come to a university. I'm a professor in industrial and system engineering, and we have 4 different subdisciplines, one of which is human factors and ergonomics, which is the study of how people use technology, interact with technology, how they perceive its use. Also things like repetitive motion task in an industrial facility, the process of understanding how they actually do the work. And then for me, I run the athlete engineering department, so we work with all the sports teams, and so that means wearables, how you interact with wearables, what you do with the data when you collect it, and so that's pretty much my role here. My favorite thing about this department is the diversity in the students, because you have some students that love data, you have some students that love to work with people, you have some students that love to work with the technology or the processes or the management, and it's all related. You think about engineering disciplines like mechanical engineering or electrical engineering, they make technology. With industrial engineers, we make technology usable. Or you could look at it like biomedical engineering, they study the human system. In industrial engineering, we study humans within systems. And so I like how industrial engineering is that interdisciplinary piece that brings a lot of those different disciplines together. My main area of research right now is athlete engineering. That probably eats up most of my time. So that really is the study of wearable technology, human performance. We work with all the sports teams here on campus, but we work with a lot of professional sports teams, a lot of other schools. It's more than just does the technology work. It's does somebody actually want to wear it? Did we just invent a really precise, expensive paperweight that no one wants to use, or did we actually make something that someone's willing to wear? Does it collect the data that the people actually need? We work a lot with strength and conditioning coaches, so they have very specific needs about what they want to see for health and safety decisions. Is the data accurate? Are they at risk of making bad decisions because that data is inaccurate? So even though this department's kind of run out of industrial engineering, we work with computer, electrical, ag and biomedical engineering, mechanical engineering, computer science. We work with kinesiology, fashion design and textile, sociology. So it's a nice bridge of a lot of other disciplines outside of just engineering. The main thing we're working on now is what we call the smart sock. It's basically a sock that's got a bunch of stretch sensors embedded in it, and it serves like motion capture, so it can capture very precisely foot pressure, foot ankle movement. Instead of having to take somebody to a lab all the time to capture what their biomechanical movements are, we can actually put it on a person and see that information outside of the lab, whether they're in industry or practicing for sports, or maybe there's some older adult and home healthcare situation. So it captures the information that the strength coaches and those health and safety practitioners said they need more than anything. So that's the main product we're working on now. So the way the Smart Sock works is we have these different stretch sensors, and they're literally sensors that you can stretch, and they're exactly linear. So as you stretch them, the output from the sensor is linear to the amount of stretch. And so working with kinesiology, you can identify surface landmarks like your ankle bone, your toe bones. All of those landmarks are common across all people. So if you're a 100-pound person that's 5'2", or a 300-pound person that's 7 feet tall, you have different anthropometries, but your bony landmarks are always in the same place. So the way the Smart Sock works, it orients those sensors based on those bony landmarks, and as you orient your foot ankle around, it can tell you exactly what the joint angle was. Likewise, on the bottom of the foot, there's 3 pressure pads that can basically serve as like a pressure mat that you wear all the time. And so we can learn about your heel strike, your gait cycle. Everybody's gait is unique, just like their fingerprint and their iris. And so it's really interesting to learn about those gait patterns, especially for those more at-risk populations. Oh man, where to begin with that? So the same design concept we developed for the sock, we think we can do for all joints and all parts across the body. But I'll tell you, the main thing we've learned, and my team always gets tired of me saying this, but we've learned 10,000 ways not to build a wearable, and we've had to build many lab tools to actually test the thing we build. So what I would like for us to become is that unbiased third-party wearable technology evaluator, because we've already had to build the tools to test our stuff against motion capture and force plates. We can now do that for every wearable company. And we do have some companies that work with us now, and we get to validate their product. We get to try it with the student athletes we have, in the different sports teams today. So I want my team to be known as that wearable technology validator. In terms of how we want our product to be an influence outside the university, we want to build a product that removes the need to have to collect all the data in the lab. Real work happens in the real world. You can make the best experiment ever and it still takes place in the lab, which isn't going to have all the variables. So if you're a strength conditioning coach, if you're a health and safety engineer, if you're a military Air Force pilot trainer, if you're a nurse practitioner, the people you serve are out there. And the more data you can collect where the actual movement occurs, the better and more accurate decisions you can make. And that's the space we want to be in. We want to have the product that's known for being able to service and help those practitioners. The thing that sets our research at Mississippi State apart than other universities is because we do have such a close relationship with all the sports teams and the coaches. We've been able to kind of see through their eyes and learn from them as much, if not more, than they learn from us. And so we really appreciate what they have to do, and we're in there with them, almost on a daily basis. The students and other researchers are. So when they talk about a problem, it's real, and we're there and we see it too. And so it helps us to be bilingual, I think is a good term, where we get to be academic focused, but we also can speak the language of the experts. So I think that's what sets us apart, is that we're able to really immerse ourselves in that athletic environment, whereas you don't really see that at other schools.